Hello guys, today this is the second tutorial for electrical circuit. So this is the diagram I'm gonna make in this tutorial, and in this diagram, as you can see, there is a bunch of cells and I think multiple of resistors arranged in a particular pattern. So yeah, let's get started. As you can see in the previous tutorial, we had like a capacitive circuit. So in this tutorial, we were gonna do some resistor based circuit. So let's delete all these. I think let it be. We are gonna make a new document. So let make in the new page break, and then after we can start. So begin center, like a picture to be in the centers, that's why we are binding in the center environment, and then after we can use text picture. And now we can start drawing. So let's see, first we have a like a squared shape. So firstly we have to define the coordinate point. So let's say this coordinate point as the center, which is origin, and then after from origin we can move along x-axis, y-axis, negative x-axis and negative y-axis, and then after we can join all these points. So let's define coordinate first. So coordinate, we call O to origin, so 0 comma 0 will be the origin point, and then after as you can see, this point will be I think 3 comma 0, 4 comma 0, depending on what you wanna, like how large you wanna draw. So let's say this point A, and this will be 5 comma 0, or like let's do not like define coordinate, because it will be like tedious and like just we have to start drawing. So firstly, as you can see, from the origin there is a cell, so just we have to draw, and from O we want a cell, so O2, and then after we can give argument as a battery U1, which means it will just draw two exactly same thickness of lines, and to we can use origin to maybe 3 comma 0, 3 comma 0, and from there we want a resistor. So we want again this is called chaining of command, so again 2, and this time we are going to draw a resistor, that's why we will call capital R, and then we can define final argument, which is maybe 6 comma 0. So yeah, as you can see, this is perfectly drawn a cell as well as a resistor, and we can manipulate her, like as you can see, this is comparatively large, so we can just say 5 comma 0 or we can have put 2.5. I think 2.5 will be like optimum or with this. So yeah, it's perfect. And in the next part we can draw in the left part, but first we are going to do some node. So for the resistor we want level which is below the resistor, so that's why we will put underscore level is equals to, I think it's R1, so capital R1, and inside the battery we can also put like a node, so level also it's in the below part, so that's why L underscore, and as you can see it's epsilon, so we can put var epsilon and underscore 1, so it will perfectly put the node below each of the individual node. So yeah, it's perfect. Or you can just say epsilon, I think that will look better. No, var epsilon is much better, or simply you can just say E, depending on like how you wanna like represent. So first part is done, and then after we can proceed to next part. So you can copy all these, that will be better. And we want this time is the first part is resistor, then the cell. So you can like do in a different way. So let's define, if we want to define battery first, then we can just put -5, 0, and then battery, which is epsilon to node, and from there we want to move minus 2.5, 0, and from there which will be the resistor which is R3, and then we can finally define origin. So if we run this part, we will see exactly same, but of the left part. So yeah, as you can see, it's perfectly drawn. And now we can move for the y-axis. So let's like do. So yeah, let's draw upper resistor, which is R2 and R4. So again draw, and we wanna draw from origin, that's why O, then after 2, capital R for the resistor, and you can put level which is R2. So capital R underscore 2, which means R2, and this time we wanna put 0, 2.5, that means like 2.5 means it will just, or as you can see, figure is symmetrical, that's why we can use exactly 5 units. As you can see, from origin to right, it's of distance 5 units. So if we want symmetrical diagram, so we have to use 5 units as the length. So we do not want 2.5, we want exactly 5. So if we run this code, we are gonna see a resistor from origin to 0, 5. As you can see, it's perfectly drawn. Or you can reverse the label part, which is here in the right side, but it doesn't matter anymore. And we can copy this part, and we can draw again to -5, and this resistor is called R4. So this will draw the downward resistor. As you can see, yeah, it's R4, and I think half part almost is done. Now we have to just like draw these 4 resistor. So firstly we wanna like join R1 and R2. So R1 and R2 is R7. So just we have to like again paste, and it's 5, 0, which is this coordinate, and then after we want 0 to 5. So 0 to 5 is perfectly, and it's R7. So if we run this part, we will see this resistor as R7, and as you can see, R7 is like in the left part, so you can reverse the label. And again we can repeat this again from 5, 0 to this resistor is R8, as you can see. So just we have to replace the node, and this coordinate is 0, -5. So if we run this code, we gonna see a resistor which is R8, and yeah, as you can see, it's perfectly drawn. And we can repeat this process for these 2 sections left. So yeah, from -5, 0, as you can see, this coordinate will be -5, 0, and from there we're gonna join 0, 5, and which is resistor R6. So just we have to replace the node, and again we are gonna draw this point to this point a resistor. So again -5, 0 is this coordinate, and this coordinate is 0, -5, and this resistor is called R5. So just we have to replace the node, and as you can see, it's perfectly drawn. I think R5 we can just reverse the node position. So L underscore, that means it will just reverse the previous. So yeah, R5 is the resistor, and as you can see, So as you can see, it's perfectly drawn, like resistor in all four faces, alveolar from the origin to the particular vertices, and cell, it's also perfectly drawn. And here you can notice one thing, that resistors are like a little bit thicker but bias are thin, so you can change these settings for the whole document depending on like how you want. But here I'm gonna do for the whole diagram, so you can just define the line with it which is thick inside the square bracket, which is optional, and it sets for the whole document, sorry, whole, not whole document, whole text environment. So as you can see, this will like make the diagram little bit thicker. Yeah, as you can see, lines are thicker and resistors are also a little bit thicker, so it looks perfectly nice. So yeah, this is how you can make the electrical circuit. And thank you, and see you in the next tutorial. I will be continue making the full diagram tutorial like this one, even for more complex kind of circuit like inductor uh, and other kind of thing, capacitor, or you can say LRC circuit. So yeah, see you in the next one. Thank you.